In this video, we'll look at solving linear inequations. There are four inequality signs that you should be reasonably familiar with. So this one says that x is less than a, and that's the representation on a number line, so it's all values of x that are less than a, and we have an open circle here to say that a is not included. The next one says x is less than or equal to a, and its number line is here, so all numbers that are less than a or a, so less than or equal to a. So we used a closed-in dot to include the point of a. Then we have the statement x is greater than a, and its number line to the right. And we have x is greater than or equal to a, and its number line shown to the right. On the number lines above, we've used an open circle when we use a less than or greater than symbol, and that's when the point is not included. And then we've used a closed circle if the number is included, so that means we're using them for less than or equal to signs or greater than or equal to signs. We follow the same method to solve linear inequations as we did when we solved linear equations. The important thing to note here is that if you multiply or divide by a negative number, you must reverse the sign of the inequality. So we'll just explore that for a few seconds. So if we consider the inequality 10 is greater than 4, hopefully you'll agree with me that that is correct. However, if we multiply both sides by -1, that would give us -10 is greater than -4. However, we know that that inequality is not correct. -10 is not greater than -4. It is in fact less than -4. So if we flip the sign, it will be correct. Similarly, if you switch the expressions on each side of the inequality, we also need to reverse the inequality sign. For example, if we have 4 is less than x, then we can also write that as x is greater than 4. Solve each of the following inequalities and demonstrate their solution on a number line. So for part A, we have 5x minus 7 is greater than 3. So what we can do here is we can start by adding 7 to both sides of the inequality. So that will leave us with 5x is greater than 10. And then to get x by itself, we divide both sides by 5. And this gives us x is greater than 2. So that is the solution for the inequation. And what we want to do now is represent that on a number line. So if we put 0 here, that means 2 will be somewhere around here. And x being greater than 2 is an open dot to say 2 is not included, all the way to infinity. So we represent that with a arrow off to infinity. You can do a little check to see if you have got the inequation right. So what you could do is you could sub 2 in, or something greater than 2, and see if you've got at least the right region of the number line. So if, for example, we sub 3 in, we'd have 5 times 3 minus 7, which equals 15 take 7, which is 8. And that is greater than 3, so we know that that's fine. So you could do a similar thing. You could put 2 in and check that it's actually equal to, or you could chuck 10 in and see that that is greater than 3. For part B, we have negative 2x divided by 3 plus 4 is greater than or equal to 5. So we're going to start off by subtracting 4 from both sides of the inequality. So that will give us minus 2x divided by 3 is greater than or equal to 1. And then we're going to multiply both sides of the equation by 3. So this will give us minus 2x is greater than or equal to 3. And now to get x by itself, we need to divide by -2 on both sides of the equation. But if we do that, we need to remember that we flip the inequality sign. So we'll have just x on the left-hand side. Instead of being greater than or equal to, that's now going to be less than or equal to. And on the right-hand side, we're going to have -3 divided by 2. So that is the solution to the inequality for part B. Next, we're going to represent it on the number line. So if we put 0 here, that means -3 on 2 would be somewhere here. And we have x as being less than or equal to that. So to include that point, we colour in the dot. And then we draw our arrow out here to say that that goes off to -infinity. So once again, you could put a number that is less than -3 on 2 and check that that's correct. But I'll leave that as an exercise for you. Next, we want to consider the two lines described by y equals negative x plus 4 and y equals 2x plus 1. Part A asks, for what values of x is the line y equals negative x plus 4 greater than y equals 2x plus 1? So what we want to do is we want to create an inequality statement from that. So we want the line negative x plus 4 to be greater than 2x plus 1. So to start off, we're just going to treat this as almost an equation. So we're going to get all the x terms on one side and all the non-x terms on the other. So what we want to do is we want to add x to both sides, which will give us 4 is greater than 3x plus 1. Then we need to subtract 1 from both sides, and that will give us 3 is greater than 3x. And then to get x by itself, we're going to divide both sides by 3. That gives 1 is greater than x, or x is less than 1. If we swap the expressions to the other side, we reverse the inequality sign, which is generally how it's best to answer an inequality question. We'd put the pronumeral first. So that is the answer for part A. And what we want to do now for part B is demonstrate that solution on a number line. So if this is 0, 1 here, and x is less than 1, we'll have an open circle, and we'll put an arrow in that direction to say all values less than 1 but not included. We've got a computer to graph these two lines, so we can see that the line y equals negative x plus 4 is in the red, and it is greater than the line in blue for all of these numbers. So the x value of their intersection is at 1. So all of these values of x satisfy the requirement that the red line, y equals negative x plus 4, is greater than the blue line, y equals 2x plus 1. Of course, we don't include the value of 1 because that's when they're equal. So that's the solution if you solve these simultaneously like we did in a different video. We can also solve linear inequations using a CAS calculator. So we're going to solve the following linear equations. On the CAS calculator, go into the main menu. For part A, we want to enter the equation, which is negative 4x minus 7, and then go into keyboard and math 3 to find the inequality symbols, and we need that to be greater than or equal to 17. To solve this, we highlight it and go interactive equation inequality solve. We want to make sure we're solving for the variable x, which is in the equation, so we press OK, and that gives us our answer. So from the CAS calculator, we find that x is less than or equal to negative 6 is the solution for part A. For part B, we want to put in 7 minus 3x divided by 2. Then we have plus 4, and that says it's less than 2x. Now we highlight that and go interactive equation inequality and solve. Solve for x and press OK, and that gives us our answer. For part B, the CAS calculator tells us that the solution is x is greater than 15 divided by 7. So that is the answer for part B. After this video, you should be able to understand how to read inequality statements using the 4 inequality signs. You should be able to solve linear inequations algebraically by hand. You should be able to solve linear inequations using a CAS calculator. You should understand the graphical interpretation of a linear inequation. And you should be able to show inequalities on a number line.